So today I'm going to talk to you about a language for robot movement. It's really sort of Python DSL called FluentNAO, and an accompanying project called NAO Recorder that works with that to help build longer sequences of robot movement. So what are you going to cover today then? We're going to talk about robot movement, so how you would normally make a robot move. This kind of could apply to anything, but I'm going to focus mostly on now. We can talk a bit about how you would do animation, so more complex movements using Choreograph, which is the NAO graphical programming environment. Then we're going to talk about FluentNAO, which is an alternative way for making NAO move, and why you might want to consider using that as well as or instead of Choreograph. And finally, we're going to talk about NAO Recorder, which is a sort of companion to FluentNAO for helping you build longer sequences of movement. Alright, so how do you make robots move? I would argue there's kind of three basic techniques. One is direct motor control, so you know exactly what motors you want to move, how far you want to move them, how fast you want to move them, and you control each motor at a time. So this is where you want very precise, very low level control, but it's quite involved. You have to know, exactly how far or how fast every motor should move in your robot, and that might be good if you want to, if you're steering a robot through a maze at high speeds. But at the same time, if all you want to do is make your robot wave hello, that's quite a lot of work. The second general technique is called inverse kinematics, and this is where you have a particular target in mind, and you don't really care what the joints angles are, or the rotor speeds. You just want the robot to reach that particular target. So, for example, supposing you've got an app where the robot needs to pick up a ball, and maybe you've identified or calculated the position of the ball using some other technique, maybe using a camera, and you just want the robot's hand to move to where the ball is. So inverse kinematics are a sort of set of algorithms that you can use to compute what all the other joints should be in order to make the hand move to the desired position. So it would compute the position of the elbow, of the shoulder, the elbow, any wrist movement, to make the robot to meet each target. And then again, here you don't really care what the joint angles are as long as the hand is where it needs to be. And then finally, there's sort of stop frame animation, and this is where you want the robot to have a series of gestures or movements that may be more aesthetic than practical. So you want it to do a dance, you want it to wave hello, you want it to salute, and maybe you want that robot that to look natural, not to look robotic or pleasing in some way. And this is basically the same as traditional animation used in anime or film studios. Is you basically move the robot into a set of positions, save those positions, do the next position, save those positions, and then the robot interpolates between them in the same way as an animated character. Basically, you make it move by having loads and loads of drawings at each position. Between sort of the sort of start and the stop. So that's quite labour intensive, but you can have excellent results if you've ever seen videos of NAO dancing. It's almost certainly done using this technique. Alright, so those are the sort of the three main ways of making a robot move. You'll see all of those used in NAO, although mostly it'd be direct motor control or animation. But let's look about why you might want something different. But before we do that, let's look a bit more about what it looks like in Choreograph. So let's start with an application. This is a really simple one. It happens to be one of the first applications I built using NAO. If you haven't seen Choreograph before, it's a graphical environment for programming NAOs. Under the hood it's Python, but it presents this graphical view where behavior or choices are in boxes, and you use wires or lines to connect those boxes together. So at the top level of your app, it's a single box, or in this case, and the wire on the left is from the start and it goes into stop. So it basically says when the app starts, run this box, and when the box finishes, the app stops. So let's dive a bit deeper into the app, and you'll see two things here. One is the sort of canvas view on the bottom, has a few more boxes in it, and also there's this strange thing at the top which has says behavior layers and then motion above that. So this is a style of NAO application called state machine programming, and basically what you're doing here is you're identifying a number of discrete states that the application can be in, and you're programming each state separately. So you can maybe see at the top that there's a waiting state, then there's a found someone state, then there's a start act state, a do something state, and an end act, and a stop. And the idea is that there's different sort of things going on in each of these states, and you can move between them. So you might move between looking for someone, doing something, and once you've done something, maybe you go back to finding someone again. And this helps to keep the application manageable. Otherwise, you get this huge ball of spaghetti in the canvas state as you had to try and deal with all the various. Okay, I'm now in the looking for someone state. These are the boxes I need to wire together. Oh, now I found someone and did this action. And choreograph applications can get very spaghetti-like, even with with the best intentions. So anything you can do to help reduce that is better. What we also might see is that the highlighted box is called animation. So this is where the application has an animation. In this case, it's now a hypnotist. He's pretending to wave something to hypnotize someone. So he's waving his arm backwards and forwards. So let's dive into that box. Okay, so now you'll see this is an animation box. The canvas below is blank. There are no boxes in here, and there's these sort of grey blobs at the top under where the motion layer is, and these grey blobs are the keyframes. And you'll see that they have varying distances apart. So maybe bigger movements might take a longer time to accomplish, so that the keyframes are further apart. Smaller movements might take small amounts of time, so that they can be close together. And here's a sort of zoomed-in view showing a few keyframes. So each of these keyframes represent these grey rectangles represents a point where I've moved the robot into position, I've saved its current position, and then you repeat. So what's wrong with that then? I mean, in some ways you can say nothing. People have produced really impressive apps using this. Some of the NAO dances are really impressive. People have produced apps where NAO has gone through various fitness routines. So it's demonstrated various movements for a fitness program, and you can do a lot. But I would argue that these mostly work where the animation is the primary focus. As you might have seen in my walkthrough just now, the animation doesn't really integrate with the. It doesn't really integrate with the rest of the code that well. So if I wanted to write sort of Python code where I want to do this thing, this animation, or this thing, I could do that for separate boxes. It's totally possible to do, but it kind of forces this sort of granularity. That I have to have a separate box for each animation, therefore I need boxes to choose between them. So if all I really wanted to do was like, okay, I've got a way with the left hand and the right hand, and that's something I want to do repeatedly, it means it kind of changes the shape of my code. It makes it hard for me to write Python code that has much animation in it. And my typical way of writing NAO applications is I'd like to actually have a few less boxes and more Python, because the Python I can potentially test and run separately. And using animations constrains me from doing that. The other thing about animations is they're totally static. The animation is always going to play the same movements no matter what happens. If the robot had fallen over and was lying on its back, it would still, and you triggered an animation, it would still do exactly the same actions as if it was standing up. And they can't be parameterized. So if you wanted a small wave, big wave, really a static wave, but they're completely separate animations that you have to record separately, even if it's just like maybe a difference in degree. Okay, so how can we address some of those issues? And this is where FluentNAO comes in. So FluentNAO is not aiming particularly to replace existing ways of moving the robot, because they all have their place. But it's an additional technique that you can use in certain cases where it makes sense. So before we do that, let's look at how other ways of moving now using Python. So we've seen choreograph, and I'm going to show you another way. FluentNAO is another way of using Python. But why is that? Why is FluentNAO necessary? Why not just move now using Python using the SDK? So if you were doing that, it would look something like this. So the top line is the SDK where I'm getting a proxy. The NAO key SDK has a number of sort of services, if you can see them, that do various functions. One of those is movement, which is the service AL motion. So if I want to move the robot, the first thing I need to do is get a connection to that service, or that via a proxy. The next thing I need to do is identify a number of joints that I want to move. So here I've got the joints, so the right shoulder pitch, the right shoulder roll, elbow yaw, elbow roll. I then have a bunch of angles that I want to move these joints to. I then have a fraction reader, how fast I want to move them, and I then call this motion proxy set angles function to actually make the robot move. So that's one movement. That's moving the arm to one position. If I was going to do multiple movements, or have the robot do a series of actions, then I would need to do this all over again. I probably would do something a bit smarter than just having a whole bunch of copy and paste of this code, but yeah, it's quite involved. It's not necessarily very easy to understand, and it's quite verbose. So FluentNAO then. FluentNAO was created by a guy called Don Nagy, and it aims, as I said, to move the robot using Python code. It groups movements into stanzas, which are kind of small groups of single movements, and it's much more concise than the code that we've just seen. One of the great benefits is that it can be used anywhere. You can use it in ordinary programs, you can use it in choreograph applications, you can even use it interactively. In a minute I'll show you, using the Python REPL, how you can interactively control NAO from Python using FluentNAO. So it has a great, what this means is you can develop applications which write Python code interactively, and then use what you learnt to embed that in a larger program or a choreograph box to use the application, the movement elsewhere. It's also got a fairly intuitive structure, so rather than the sort of existing NAO key API where you have separate proxies, you have proxies for movement, for speech, for other things, the sort of structure is mostly based around the robot. So you have this top level NAO object, but then you have like all the movements around head are grouped onto the head, sub object, legs under legs, arms under arms, elbows, hands, and so forth. And then you have sort of things that are sort of miscellaneous, like various postures, speech, and walking. So you can do a lot of things with FluentNAO, and it's mostly structured in a way that makes sense based on the structure of the robot itself. So what does it look like then? Let's take some really simple examples. So if you want the robot to say something, you just do now say. You can reach basic postures by saying now stand, now crouch, now arms up, now hands open, and things like arms up and hands open are kind of interesting because I'm not saying how much to move the arms up or how much to open the hands. And so this is where sort of default parameters come in. So although up just means it makes the robot hands move right up, you can then add parameters if you want to fine tune that. But you don't have to. If the default is what you want, then you don't need to give it any extra detail. So let's have a look at a slightly more complex behavior. Here we're doing a kind of salute where the robot moves his hand up to his forehead, moves the salute, and then moves his hand down again. Now, this is still quite a chunk of code, but I would argue that it's somewhat more easier to read than the code we showed earlier, because at least you can see from there what arms am I moving, and it's kind of grouped by joints, so it's a bit easier to parse. It's made more complex because for this one we've used specific joint angles that we found, but you can see that it's basically the go function at the end there is what tells the robot to actually go and move in that position. So you can see there's basically three main chunks, three main movements here, and at the top here we've set the duration to 1 second, which means that the robot will aim to complete a movement every second. So we'd expect this animation to run in about 3 seconds. So demo. Okay, I'm now going to run FluentNAO interactively, and we'll see how you can make the robot move with small amounts of Python. So one of the slight annoyances about writing code for NAO these days is that the NAO SDK is in Python 2, and hence the FluentNAO itself is written in Python 2. And if you want to experiment, that would mean installing a bunch of Python 2 libraries. But Don has made this easy for you by adding a definition of a Docker file to his repo, and so you can very easily spin up an environment for running FluentNAO code, even if you don't have Python installed on your machine. So we'll start with doing that. So first, there's a make command that actually runs Docker Compose and spins up Docker, and you can see here. Okay, so that's only took a couple of seconds. Let's make the robot stand up using our first FluentNAO command. So you can see that's fairly easy. There's no proxies or anything else. It's just telling the robot to now stand. Again, let's do something simple. Let's make the robot say something. Unfortunately, there's no audio in this video, so you won't hear it, but you can at least see in the code that actually now say. It's again fairly easy. Now animate, you can use animated say, so you have the robot move his arms while it talks. Again, this is all pretty straightforward, and we use now stand to get the robot back into the default position. So let's look at actually more granular movement. Let's say we want to have the arm up and forward. As you can see, again, arms right forward. I've pasted in a joint command there, so it's slightly custom, but easy to see what's going on. And let's make the hand open, and we can make the hand close. And again, you can see now hands right open, now hands right close. It's pretty easy to work out from the code what's going to happen. And again, you put the robot back into the default position. Now that's pretty neat. It's easy to understand. It's already more concise than the raw NAOkey API would be. But one of the benefits about FluentNAO is it's just Python code, so you can build functions that call this and then just call them. And here's an attempt to do a salute, but I've got it slightly wrong. You can see that the arm isn't moving down again, and if you look at on the left there, the clue is there's a comment saying down to neutral, but you won't see any command, so I need to fix that. And these are examples taken from Don's FluentNAO repo, by the way. They're not ones that I've put together. But you can already see how powerful it is to combine groups of movement together in functions. You can imagine, from this, that you could parameterize these functions. If I wanted a fast salute or a slow salute, that would be as simple as passing a speed parameter in and changing the now set duration at the beginning of this function. So let's try again, hopefully with all the movements this time. And that's a much better salute. And again, it's a function, we can call it as many times as we want. So how about we do that again? Or not. Okay, let's try a different function. Let's make now wave. Yep, easy. And again, we can do that again. It's a function. You can just call it. There you go. Okay, and again, the code is fairly straightforward. One last example, again, stolen from Don's repo. This one we'll combine speech with movement, and you'll see how easy that is to do with Fluent NAO. So we've got this tada command that takes the now function, now object, and something to say. So in this case, we'll say I did something. Yeah, that's kind of cool. And again, you can't hear the speech, but the robot is speaking at the same time. So hopefully now you've got a flavour of what it's like to program with Fluent NAO. And I wanted to show this way because you can see that it provides a way of experimentation. You can just sit there, the robot turned on, have your terminal open, and just try stuff out. So it's really easy for prototyping. Because the Fluent NAO API also includes things as well as speech. It has movement. You have callbacks. You can write. You can in many cases replace much of the standard NAO API with Fluent NAO and have much more concise Python code. The way you can combine movement code into functions and parameterize the functions, I think, is a game changer, because again, you can write much more standardized Python programs that you could potentially run outside the choreograph and test outside the choreograph without being overwhelmed by boxes, and also making use of standard Python formatting and linting code. And so I think it really is an interesting approach and worth considering. So one of the advantages of Python is you can inspect objects and find out more about them, and you can use this approach with Fluent NAO too. So the default Fluent NAO object that represents the entry point to the API is called now, but we can inspect that to find out more about it, and we can do that using the dir, the dir function, Python. So if I call that on the now object, you'll see that I get a bunch of values back. Some of them are internal Python things like the dunder attributes. Some of them are perhaps less obvious, so things like let's see, whole body disable, whole body enable. You might want to go and see what those do. Some like move, the postures like lying belly, stand, crouch. Fairly straightforward. You'll see there's bits around the parts of the body like hands, so arms and legs. But you can get a feel for actually, what possible actions you could do and experiment with. And you can take this further. So you can take the now object and then look at parts of it. So let's look at, for example, the head. And again, you'll see there's sort of various attributes on it. The arms, so here's maybe a bit more obvious. You've got left relaxed, left stiff, left up, left down, some of the things we've seen already. And you've got hands, so again we can keep going and we can say, okay, what attributes are available on the hands. And again, you can see there's right closed, right open, left closed, left open, left open. So that gives you an idea of what you can do with the SDK or the part of Fluent NAO, even without actually reading any docs. Some bits your signature docs work are probably the whole body stuff. Some things around movements and constraints motions, the more complex stuff, you probably want to read some documentation about. But in terms of thinking, oh well, what options can I call to hand, you can figure this stuff out by yourself just using Python, built-in Python techniques, which I think is pretty cool. Okay, so you've seen a bit about how FluentNAO can be used, how it can be used interactively. So I hope that gives you some flavour of what it's like to use it. It can do quite a lot. I've really only given a quick taster here. It has commands for moving the robot as well, for making it walk. So you could build substantial applications using the FluentNAO API for much of what is currently used. Well, you can't use the existing NAOkey API. Okay, so having talked about FluentNAO, I'd like to move on to NAO Recorder, which is sort of a companion project to FluentNAO. So FluentNAO is great for short segments of movement. It's quite intuitive, so you can have a pretty good idea of what commands you need to use. You then might need to do some experimentation to work out how much to move the arm. So you might have an arm up and you want to tweak that a bit more, and that might take some iteration. But as you've seen, you can do that interactively just using the Python shell. But it can still take a while. And again, longer animation. The longer animation, the longer that can take. So this is the problem that the kind of NAO Recorder aims to solve. It's like, okay, what if you could have the ease of use of something like the choreograph animation mode, where you're moving the robot into the exact position you want, but you could still generate Python code that did those movements rather than a animation that then is hard to integrate with. And again, that's exactly what NAO Recorder aims to do. It uses the Kiwi UI library to give a sort of somewhat nice or slightly more modern appearance. So we'll delve into that, and we'll do that mostly by a demo of the app itself. And you can also find this demo on YouTube. Okay, so I'll just take you through the basics of the user interface of NAO Recorder. So the first thing to do is connect to the robot. So you enter the robot's IP address or hostname and hit the connect button. So now I'm connected to the robot, and I can see four main regions of the user interface. There's the toolbar at the top, there's the code input window, there's the status window, and there's the representation of the robot, which shows me which motor chains are on and which joints are going to be recorded. So I'm going to start by turning speech recognition off, so the robot won't attempt to recognize what I'm saying here. And you can see that I've got confirmation in the status window that speech recognition has been turned off. Also, the robot will say that speech recognition has been disabled. So let's just go through the toolbar first. So the file menu is pretty standard. You can have options for reconnecting to the robot, for opening and saving files. You just saw me use speech recognition. So one way of controlling NAO Recorder is to talk to the robot, and so you can give commands telling the robot to stand, to sit, to relax or stiffen a joint chain, and depending on your environment and your voice, these may work sometimes good and sometimes not so good. So you can turn that off if you don't want it. Likewise, you can use the touch sensors on the robot to stiffen and relax joint chains. So the back of the head will stiffen or relax the head. So while you hold it down, it's relaxed, and if you let go, it will stiffen again. The backs of the hands will stiffen and relax the arms, and the foot bumpers will stiffen and relax the
the legs. If you don't want that behavior, you can turn touch sensors on or off by clicking the touch sensors button. So now touch sensors are off, and I'll turn them back on again. You can control whether the motors are on or off. By default, the motors are off, and that's indicated by the motor buttons being green, and green in the chain buttons here. If I turn motors on, then it goes red to show that joints are stiff, and you can see on the robot representation that all the various joint chains are stiff because I've turned the whole thing on. Run script allows you to run the script currently in the code window. Now if you're recording to JSON or EDN, then that's a data format, so that's not runnable. So in that case the run script button is disabled. But for FluentNAO code, you can always run it using the run script button. At the moment it now just says hi, so if I run that, the robot will say hi. The action menu allows you to put the robot into various standard postures. So you can make it sit, lie on its belly, stand, and so on, and basically use that to reset the posture before or after recording some movement commands. The add keyframe button is used to add a keyframe. So just as with choreographs animation mode, you'll put the robot into position, and you can either hit the add keyframe button, or you can tap the front head sensor to add a new keyframe. Read joints reads the current state of the robot. So if you want to put the robot in a position and only record differences from that position, you put the robot in the position, you click read joints, and then only changes from that position will be recorded. Keyframe duration is the time between keyframes. By default this is 1 second. You can edit it to make it smaller or whatever number you like. And you can also edit it in the keyframe window, so the code window, as we'll see later. The final button allows you to choose what formats you're going to record to. Currently, NAO Recorder supports 4 formats: FluentNAO, which is Python code, JSON format, which is just data, EDN, which is closures equivalent to JSON, or Nausea. Nausea is a library that I've developed that is similar to FluentNAO but written in Clojure. So for now we'll stick with FluentNAO. Okay, so the robot window. So this shows me 2 things. It shows me what joint chains are stiff by these bars here, and what joint chains I'm going to be recording. By default they're all enabled. If, for example, I wanted to record just the right arm, I could click the body to toggle them all on or off, and then just click the chain I want. I can also click particular joints. If I want just the hand or just the wrist, I can do that too. Or again, I can just toggle the whole chain. Same for the head or any other joint chain. So the code window is also editable. So I'm going to now turn the motors off to make the robot flexible, move the arm, and record a keyframe. Actually, first I need to enable the joint chain I want to record. And I could tap the front tactile sensor, but I'll do the add keyframe here so you can see what I'm doing. And here you can see that FluentNAO has generated a stanza of code. The duration for the keyframe is set here. So if I wanted to make that keyframe shorter, I can just edit this parameter here and say make that 1/4 of a second. So you can see that this keyframe involves 2 FluentNAO commands. I'm moving the arm to the left forward and the elbows, and then that launches the command. So let's do one more. Read the joints. Add a keyframe. Add another keyframe. Now I'm going to turn the motors on. Put the rope back into the standard sit position. Now I have these two keyframes. They've gone back to half a second. I'll leave them like that for the moment. And if I only want to run one of them, I can select the text to run and hit the run script button. Likewise, I can select the second one and just run that one. Or I can just hit run script and run them all. And once I've finished, I can again initialize the robot into the standard sit position. So that's the basics of the user interface. I'll now just want to demonstrate how you can record to JSON and then convert that. So I'm just going to clear this, change to JSON format, and again I'm going to record a couple of keyframes. Okay, I'm going to just click the button here to toggle stiffness off. Record one keyframe and another keyframe. And I'll put the rope back into sit. Now, I can save this JSON file as data, but the other thing I can do is, because JSON is sort of just a data format, I can also convert that to other formats. So if I click on the format menu and select Fluent NAO, I'll get a prompt warning me that the results may not be exactly equivalent. For JSON, it probably will be, but I'll click OK to go ahead. And now I see the Fluent NAO code that's equivalent to that JSON. The same is possible for EDN to Fluent NAO, or for JSON to Naojure. Currently, you can't convert from Naojure or Fluent NAO to another format, but that will be coming in a later release. Okay, let's record another animation. Let's maybe have him look his head left and right, and then wave his arms.
Head relaxed. Head stiff. Head relaxed. Head stiff.
Okay, let's just run that so far. Okay, let's add some arms. So,
Left arm relaxed.
up there,
Left arm stiff.
keyframe. Let's grab everything. That's how I use the UI to turn the motor off. Stiff. Grab a keyframe. And wave it down there. And grab the trigger again. So let's put it back into his neutral posture. And run that.
Okay, so that was quite a lot about NAO Recorder. What next? So, NAO Recorder is written in Python 2 because that was written a while ago, and also the Python SDK is written in Python 2. To be useful now, it should really run in Python 3. And that means we need to write a way of using the existing SDK with Python 3. So this is really a kind of a call to action here. Is, does this approach seem interesting? Does it seem like a worthwhile alternative or addition to the suite of NAO programming techniques? Is this an approach that you think is applicable to more humanoid robots? Here, we focus only on NAO, but there's no intrinsic reason why you couldn't use a similar approach with other humanoid robots like Alpha 2. Are there things where the app could be made better? So yeah, let me know in the comments. Join us on the RoboHack Discord. And I would work the app, FluentNAO and NAO Recorder. They're both open source. They're both on GitHub. I'll put links at the description of in the video below. Yeah. So, what do you think? Is this interesting? Let me know. Thanks.